Hey everybody, welcome back from the break. I'm sure you are all excited to be here today and ready for the second semester. We're starting a new unit. This unit is about solving systems of equations, and we're going to look at a variety of methods over the next 2 weeks for solving different systems. Today we're going to work at looking at elimination, which is a method to solve these systems. This is not in your foldable, but some vocabulary that you need to know before we start today. A system of equations means two or more equations. We worked on this a little bit before the break with our parallel and coinciding lines. A solution is an ordered pair that makes both equations true. When you have infinite solutions, that means the lines are coinciding, or it's one line on top of itself. It's the same line. And no solutions will happen when there are parallel lines. You're going to be looking at your foldable today that says Solving Systems of Equations by Elimination. This method works best when you have two equations that are both in standard form. Remember that standard form is ax plus by equals c. So we're looking for equations that have standard form. And when we have elimination, our goal, the reason it's called elimination, is to get rid of either the x variable or the y variable. So we want to eliminate one of the variables. The best way to eliminate a variable is that they have opposite coefficients. So one coefficient might have a positive 3 and the other one might have a negative 3, or one might have a positive 2 and the other one has a negative 2. So we need opposite signs for our coefficients to help us eliminate these. Now, looking at our equations, for example 1, we have 3x plus y equals 2, and then we have x minus 2y equals 10. Now, when we solve this, I'm looking at these. My x's have the same sign in front. They're both positive. My y's have opposite signs, so that's good. But now they need to have the same coefficient. I can take the first equation and we can multiply so that they have the same coefficient. If I take this equation and I want this y value to have a positive 2 coefficient, I can multiply the entire equation by 2. If we multiply the entire equation by 2, this would give us 2 times 3x, which is 6x, then 2 times a positive y, which is positive 2y, and then we have the equation 2 times 2 on the opposite side of the equal would be 4. Remember, what we do to one side, we do to the other, so we're going to multiply everything in our equation by 2. These two equations are equivalent. Multiplying by 2, if I multiply the entire equation by 2, does not change anything. Now, I'm going to rewrite the first equation at the top, and the second equation is going to go right underneath it. Notice that my x values are in line, my y values are in line, and then my constants after the equal are in line. Now we can combine these two equations, and that will help us eliminate the y values. We're going to add the first and second equation together. So 6x plus 1x would give us 7x, and then 2y plus a negative 2y, or 2y minus 2y, would be 0y. And if it's 0y, what's happened is that these actually cancel out, because 0 times y would just be 0. Notice they have positive 2 and negative 2 for the coefficients. Those opposites can cancel out. After our equal sign, we would have 4 plus 10. 4 plus 10 is 14. So now we can solve for the x value. Here, 7x equals 14. That tells us that we know that if we divide both sides by 7, then x has to equal 2. That is part of our solution. That is not the end of the solution. Remember from our vocabulary page, a solution for a system of equations is an ordered pair. We have the x value of our ordered pair. Now we just need to find the y value. I can choose either of the two equations that we started with, and I'm going to plug in that x is 2 to find our value for y. I'm going to choose the first one, so we have 3x plus y equals 2. It doesn't matter which one you pick, your y value should be the same. So 3 times 2 plus y equals 2. So 6 plus y equals 2. That means that when we subtract 6 from the left and the right of this equation, then y equals a negative 4. So now we found our x value and our y value. That means our solution as an ordered pair is 2, comma, -4. This is the solution to our equation. It's an ordered pair, and it's a value that would work in both equations. If I take 2, -4, and I plug it back into check for this, I would have 2 minus 2 times -4 in my equation. If I plug these values right here back into our second equation, 2 minus 2 times -4, well, -2 times -4 is 8, so 2 plus 8 would be 10. That's a true statement. This ordered pair works in both equations. All right, looking at our second example, we have 2x plus y equals 6 and -4x minus 2y equals 5. Remember that our goal is to eliminate the x or the y, and this works best when they're in standard form. So these two equations are both in standard form. We can look, let's just start with the x's. We have 2x and -4x, and the y's, we have a positive y and a -2y. So I'm going to take one of my two equations, if needed, and multiply so that they have opposite coefficients. I'm going to look at the x values this time. I have a positive 2 and a -4, so I know that I can take this first equation and multiply by 2, because 2 times 2 is positive 4, and the second equation has a -4. So going over here to rewrite this equation, so 2 times 2x would give us 4x, and then 2 times y is a positive 2y, and 2 times 6 is a positive 12. So we would have 4x plus 2y equals 12. So we've taken the first equation and we've multiplied everything in it by 2. That way the coefficient is a positive 4 for x. Now my second equation, I'm going to rewrite it. I'm going to write it directly underneath it where my like terms are lined up. So we have our 4's, our x's lined up, our y's lined up, and our constants lined up, and our equals also in line. Now we're going to look at these two equations and we're going to add or subtract. We're going to add the two equations together. So 4x plus -4x, well, 4x plus -4x is going to cancel out because 4 minus 4, or 4 plus -4 is 0, and 0 times anything is 0. Then we look at our y's. We have 2y minus 2y, or 2y plus -2y. Those are also opposites that would cancel out. So now we have 0x and 0y. Well, 0 times x is 0, 0 times y is 0, so 0 plus 0 is 0. On the other side, we have 12 plus 5. Well, 12 plus 5 is 17. So now we have a statement that says 0 equals 17. Since that is not possible, it is impossible for 0 to equal 17, and we don't have any variables because all of our variables have canceled out, we would say that this is a false statement, so there are no solutions. If you end up with a false statement and there is nothing that you have left for x or y for your variables, it is impossible to have a solution for this. There are no solutions. Our last example, example 3, we have the equation -x plus 5y equals -6, and we have 2x minus 10y equals 12. Notice that both of these are written in standard form. We have ax plus by equals c, so we've got our x term, our y term, and then our constant after the equals. We're going to make sure that one of these, either the x values or the y values, have the same coefficient with opposite signs. So I've got -x and 2x, I've got 5 and -10y. I'm going to look at my y's, since I know that 5 and 10 can go nicely together. I can take the first equation and multiply everything by 2. When I multiply by 2, that's going to give us a positive 10y, which will cancel out with my -10y. So when we multiply by 2, 2 times -x will give us a -2x. 2 times 5y is a positive 10y, and then 2 times -6 is -12. Now we're going to write the second equation right underneath that. We have 2x minus 10y equals 12, and we're going to add these two equations together. When I add -2x and positive 2x, these cancel out and give me 0x. When we add 10 plus -10y, or 10y minus 10y, that gives us 0y. They cancel out. And we know that 0 times x plus 0 times y, well 0 times x is 0, 0 times y is 0, and 0 plus 0 equals 0. After our equal sign, we have negative 12 and positive 12. So negative 12 plus positive 12 gives us 0. Now we end up with the equation 0 equals 0. Since this is a true statement, 0 is equal to 0, that's true. When we have a true statement and there are no variables, the x's and y's both canceled out, this would have infinite solutions. That means that if I find any ordered pair on the first line, it is also an ordered pair on the second line. So if we have a true statement, it's infinite solutions, and any ordered pair that works with one equation would also work with the other equation. There would be infinitely many ordered pairs on both of these lines. They would be coinciding lines. That means if I graph these two, they're going to be the same line.